maximum subsequence score. So we are having two arrays, nums1 and nums2, and we are also giving an integer k. Yeah, we need to check some conditions. Yeah, so both arrays are 0 indexed integer arrays, and the length of the array is n, and we also have integer k. So this k means we can take k element from nums1 and nums2. Yeah, so the sum of the selected elements from nums1 multiplied with the minimum of the selected elements from nums2. So we are going to calculate something like that. Yeah, so here is just the formula. We need to return the maximum possible score. Yeah, so the subsequence of an array, you need to know about that. We just need to take some element from this array. So this is the subsequence of an array. This problem is exactly the same as Leetcode problem. Let me go. Yeah, exactly the same as the Leetcode problem 1383, maximum performance of a team. If you don't understand that problem, maybe you need to check my video about maximum performance of a team. Yeah, because they are exactly the same, and I've already explained exactly how to do it. Yeah, so this is why sometimes we can solve the problem immediately, because we've solved this problem before and we recognize the pattern. So this pattern is called sort plus priority queue. Yeah, we are going to get the sum of the numbers in nums1, as you can see from that, and we are also going to check the minimum of the element in nums2. So for example, here the minimum is 1 and the sum of them is 7. So when we get a result of 7, and finally we get the maximum of all the possible results. Why we can do it using sort and priority queue? Because for the first array we just needed to sum all the elements, we don't need to get the maximum or minimum value. But for the second array, we just needed to get the minimum value. So this means we can use a min heap. After using min heap, we can get the minimum value in log n time. So the time complexity becomes n log n. Yeah, this is why we can use this kind of a method to solve the problem. Normally, this n should be 10 to the power of 5, as you can see from that. Otherwise, you cannot pass. If this n is 10 to the power of 8, of course not possible, or 10 to the power of 6, maybe not possible. But it is designed for 10 to the power of 5. It means we can use n log n time to solve the problem. Yeah. Because we can use min heap to store the values inside the nums2. So this means we can do some sorting of nums2 to get the element in decreasing order. So let me give you an example of nums2. So yeah, let's just take this nums2 from here. We get all the elements from nums2, but what if we sort the element in nums2? It's going to be 4, 3, 2, and 1. Here I don't prepare the element from nums1 because there will be no influence. We just need to analyze this nums2 first. Yeah. So for the element in nums2, so for example, if we choose the first element, what is the lowest element? It is 4. If we choose the first two elements, so what is the lowest element? It is 3. It is exactly here. If we choose 3 elements, 4, 3, and 2, what is the minimum element? It is still 2. If we choose 4 elements, so the minimum can still be 1. So this means after looping through the array, we can always get the current element as our lowest element, and this only takes log n time. This is why we can use PQ, priority queue, or min heap to solve the problem. Yeah. Now let's just try to solve the problem. I mean, at the same time, we need to check the sum of the element inside nums1, and we need to track the element. If there are more elements, we need to replace them. Yeah, but I will explain it later in my code. Yeah, now let's just start coding. So I'm gonna prepare a result and a total. Total is the sum of the element in nums1, and I also need let me check. Do I need to prepare anything else? Yeah, let me just prepare a result and total. Yeah. Now let's check the element in nums1 and nums2. So for n1, n2, in I'm gonna use a sorted zip. Yeah, so the zip would be nums1 and nums2. Because I want to sort the element in nums2, so I'm gonna use a lambda function. So k should be equal to lambda, and I need to choose the element of the second element. So x should be the second element, and it should be in decreasing order. So here I'm gonna use a negative sign to make it in decreasing order. And also this array has already been sorted like that according to the second element in decreasing order, because I'm going to check this 4 first. Yeah. Currently we are sure this n2 should equal to 4 from here, from this example. Yeah. Now what about the total element? The total should be plus equal to n1. Yeah, because in n1 we need to keep track of this total, and n2 is our current element. And what could be the result? So the result should be the maximum of the result with this n2 times total. Yeah. Finally, we're gonna return the result, but this is not the end of the code. This is just some analyzation of how to solve the problem. Yeah. Now we get a total should plus this n1. Yeah. Now we need to check. We need to put the element inside the priority queue. We need to put n1 inside. Yeah, let me check if it is n1 or n2. Yeah, we need to put n1 inside the priority queue, because inside our main heap we need to check the sum of all the elements. Yeah. So we can use heap push with pq and n1. So we need to prepare another variable. It's gonna be the pq. The priority queue would be an empty array. Yeah. Now we put n1 inside. For example, this 4 should be 2. Yeah. 4 mapping with 2, so 2 would push inside our priority queue. Yeah. If I push 2 inside, next I'm going to check the length of the priority queue. If it is more than k, it means I need to, yeah, pop it out the element, because there are 2 elements, too many elements. Yeah, I need 3 elements. Currently it is 4, so I need to pop it out. If I pop out an element, because it is a min heap, so I get a minimum value. So this mn means minimum. So the minimum element would be equal to heap pop, and inside gonna be pq. And what about the total? The total should be updated with minus this minimum element. Yeah. So what about our result? We need to check if this length of the pq equal to k, and we can get our result, because it is exactly k element. Yeah. So that is the only difference from the performance problem. And for this maximum performance of a team, it is at most k element. Yeah, but for our problem, it is exactly k element. So we need to be careful. Yeah, we need to read the problem careful. We need to be careful with this kind of descriptions. Otherwise, maybe you're gonna make a mistake, because we need to choose exactly k element. It is not at most k element. I think this is gonna be the entire code. Let me just run it to check. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases, and it's pretty fast. The time complexity, yeah, let's just analyze the time complexity from here. So the time complexity, first of all, we have a sorting. The sorting of the array is the nums1 and the nums2, so it is n log n time. Another one is just from the heap, min heap. So the min heap, there are at most k elements inside the min heap. So how many? So what is the loops? The loops is n. So there are n loops. So n times log k. So this is the final time complexity, n log n plus n log k. And the space complexity, because this is a priority queue, we used at most the length of k. So the space complexity is O k. K is the length of this array pq. Yeah. So this is the entire code and solution. Thank you for watching. See you next time.